Hello everybody, we're going to start exercise number 2.5, but before we start this exercise we need to discuss some basic properties which will help us to solve various questions given in this exercise. And those properties are: first one, nature of the roots of a quadratic equation; second, relationship between roots of the quadratic equation and coefficient; and third important part of this exercise, to obtain quadratic equation. Here we will obtain quadratic equation having roots, which means roots of the equations would be given in the form of question, and we will retrieve original quadratic equation. So here we will do our work will be in reverse manner. Previously we had many different kinds of quadratic equation, and we found roots of those equations or solutions of those equations. But in these questions you will have roots of the quadratic equation, and you will be required to obtain original equations from their roots. Now we will take this first one. What are the different roots of the quadratic equation? Now natures of the roots of the quadratic equation. This is first part of our discussion. Nature. So when we talking about nature, so this nature is actually depends on this delta. This is delta sign, whose value is b square minus 4ac. This b square minus 4ac is same which we used to write in our quadratic formula. Um, this is our quadratic formula. We have already discussed about this formula in exercise number 2.4. Minus b plus minus root of b square minus 4ac upon 2a. So the value which is written within the root is same, that is b square minus 4ac. So same value, this value is called delta or discriminant of the root. So this delta you need to know in order to identify nature of the root. So when you substitute value of b, a and c from any given equation to this formula, in this formula you will get a real value for this delta, and that real value can be of three types. It can be greater than 0, it can be less than 0, or even it can be equals to 0. So if your delta is greater than 0, if your delta is greater than 0, then equation will have real and unequal root. So nature of the root will be real and unequal. Now the second condition, if your delta is equals to 0, this is second condition where the value of delta can be equals to 0. So nature of the root will become real and equal. Real and equal. And third one, if the value of the delta is less than 0, then equation has no real root. No real roots. So these are three natures of the roots of the quadratic equation which we need to study in this chapter. Now the first nature of the root is real and unequal. When we can say the nature of the root is real and unequal, when value of delta is greater than 0. For example, value of delta is like 5 or any positive number greater than 0. It can be 1, 2, 3, 4 and onwards. Any positive real number. Same way, if delta is equals to 0, which means value of delta is 0. So here you can say delta equals to 0. Then nature of the roots will become real and equal. And third nature, if delta is less than 0, then equation has no real root. Equation has no real root. Like if value of the delta is -2, -1, -3, -5 or any negative real number. So hope it is clear to everybody what are the different natures of the roots. So in this syllabus we will study these three natures of the root. Now let's move on our next property. The relationship between roots of the quadratic equation and coefficient. Relationship between this is very important. Whenever we solve any quadratic equation, we know we are getting two roots of the equation, and those two roots of the equations can be considered as alpha and beta. Symbolically, we used to write them as if roots of the roots means solution. Roots of the equation are alpha and beta. So these are two roots of the equation, alpha and beta. Then sum of the root that is alpha plus beta. So this alpha plus beta will become minus b upon a. Sum of the root that is alpha plus beta, which can be taken as minus b upon a. So remember this, b upon a is sum of the root. What is b? B is coefficient of middle term and a is coefficient of first term. Because we know that the quadratic equation is ax square plus bx plus c equals to 0. So this is your a, this is your b and this is your c. So b minus b upon a is sum of the root. Product of the roots. Product of the roots. Product of the roots, that is alpha into beta, is equals to c upon a. C upon a. C is coefficient of third term, a is coefficient of first term. So this is called a relationship between roots of the quadratic equation and coefficient of the quadratic equation. Now third and last part of our discussion is to obtain a quadratic equation having given roots. So here this is third property which we are going to discuss now. In this part here we will discuss how to obtain original quadratic equation if roots, that is final solutions of the equations, are given. So suppose if alpha and beta are the roots of the any quadratic equation, then that equation can be obtained as x square minus alpha plus beta into x minus plus alpha into beta equals to 0. This is also this we can call general form of the quadratic equation when alpha and beta are known and you wanted to retrieve your original quadratic equation. So this formation can be used. In this formation, this alpha plus beta is nothing but sum of the root and alpha into beta is product of the root. We initially discussed about this. So you just need, if alpha and beta are known, that is two roots of the equation are known. So you just need to add those two roots and multiply those two roots and just club them in this formula along with x or any desirable uh, variable which you require. Here we talking in terms of x. Now we can move on exercise. So uh, these questions, this is your question number 1 from practice set number 2.5, and these are activity based question which one can solve easily. We will just discuss these questions. Now your question says activity number 1, fill in the gaps and complete. Your quadratic equation is ax square plus bx plus c equals to 0, where b square minus 4ac is 5. The value of delta is 5, which means here in this case delta is greater than 0. We have already discussed what could be the nature of the root if delta is greater than 0. So if delta is greater than 0, then equation uh, will have real and unequal roots. So this equation in this case it has real and unequal root, real and unequal root. Same way b square minus 4ac is minus 5. So in this case the value of the delta is less than 0. If value of the delta is less than 0, then equation has no real root. So here you will write no real root. Nature of the, in these two blank boxes we need to write natures of the root. So in this case nature of the root is no real root. This equation will have no real roots. Same way, this question number 2, sum of root is minus 7 and product of the root is 5. So sum of the root means alpha plus beta, right? Product of the root, that is alpha into beta. So these two values are already given. Here we have blank space. So what you will fill here? So here you need to write quadratic equation, means from which quadratic equation these roots, these values are taken. So the form of the equation is x square minus alpha plus beta into x plus alpha into beta equals to 0. So this is general form of the quadratic equation. As per this form, what we will do, here we will write x square minus alpha plus beta is negative 7, so this minus minus will become plus 7 x plus alpha into beta is 5, so here I'll take 5 on the place of alpha into beta equals to 0. So this is your required equation which you can write in this blank space. Now come to this question number 3. If alpha and beta are roots of the quadratic equation and 2x square minus 4x minus 3 is equals to 0. This is what? This is quadratic equation. So we need to find out alpha plus beta and alpha into beta. We know alpha plus beta, that is minus b upon a. This is as per our third property which we just discussed in this video. So minus b upon a. So in this case here a is 2, b is minus 4 and c is minus 3. So minus b upon a, that is minus 4. So minus minus will give me plus 4 by a, that is 2. So this will become 2. So a plus b is 2. A into b, that is product of the root. Product of the root is c upon a. C, that is coefficient of third term upon coefficient of first term. C in our case is negative 3. A will remain as 2. So alpha plus beta is 2. Alpha into beta is 3 by 2. So this is your solution for this question number 1. Now let's move on this question number 2. We will solve this question number 2 where we need to find out value of the discriminant, which is very important, very simple part of this exercise. Here a quadratic equation is given. We need to find out value of the discriminant. Discriminant means delta. So I'll take this question on a new sheet to find the value of discriminant. This is your question. You need to find out value of discriminant. In order to find the value of discriminant, first you need to compare this equation with standard form. Comparing. Why we are making comparison? To get the value of a, b, c. Comparing with ax square plus bx plus c equals to 0. On comparison, we came to know that a is 1, b is 7 and c is minus 1. Now we need to find out value of the discriminant. So delta is value of the discriminant and delta is b square minus 4ac. So b square, that is 7 square minus 4 into a into c. 7 square, that is 49. This negative 4 and negative 1 will become positive 4, and again we will multiply 4 with positive 1, so it will remain as positive 4. So 49 plus 4, 53. So this is value of the delta. So here value of the delta is 53, which means this is final answer as per your question. Suppose if you want to identify nature of this equation, roots of this equation. So here we will make comparison. Since 53 is greater than 0, so here we can say delta is greater than 0, and we know if delta is greater than 0, then the equation will have real and unequal root. So this equation, this given equation has real and unequal root.